Dear aspirants, welcome to my channel. This is an concepts of electrical circuit model question paper 3 5 marks question. Remaining questions I am going to explain this video. The first question is compare electrical circuit with a magnetic circuit. So first one is electric circuit. The flow of electric current takes place. Current is measured ampere A. EMF force is driving force. Unit for EMF force is volt. Opposition to current is resistor R. It obeys Ohm's law. Current flows through a conductor. Resistance depending on resistivity. Electrical energy is converted into heat. Example, we can use it for batteries and resistor circuits. Next is magnetic circuit. Flow of magnetic flux takes place. Magnetic flux measured Weber or WB. Okay. Magnetic force, it is driving force. Unit for MMF is ampere turn AT. Opposition to flux is reluctance S. Ampere's law is used. Flux flow through a magnetic path. Reluctance depending upon permeability. Magnetic energy stored in a magnetic field. Example, you can use it for transforms and electromagnet. Next is electromagnetic induction with illustration of conductor moving in a magnetic field. Before going to the what do you mean by electromagnetic induction? Electromagnetic induction is a phenomena of a producing EMF force or electromotive force in a conductor where the magnetic flux linked with it changes. This force, it is depending upon Faraday's law. When a conductor moves in a magnetic field and cut magnetic line force, EMF induced in a conductor. So coming to the working principle, you see the diagram here. You just see the diagram, conductor moving magnetic field. When a conductor AB is in conductors moving a right and cut the magnetic flux and EMF is induced. AB moving is a magnetic motion and magnetic field in EM induced. So coming to the Faraday's law, this is the equation. You can see the equation E is equal to minus n d phi by dt. EM E small e is equal to induced EMF. N is a number of turns and magnetic flux and times. So it should be, you can use this also, magnitude induced EMF E is equal to capital BLV sin. So working principle, consider a straight conductor moving between north and south poles of the magnet. The conductor cuts the magnetic flux while moving. Due to cutting action, EMF induced in a conductor. If the conductor forms a closed circuit, induced current flows through it. The direction of the induction current determined the Fleming's right hand rule that I have given above diagram. So you can write more marks. Write an application. Application, we can use it for electrical generators, transformers, induction motors and bicycle dynamos we can. Next is derive the formula for an inductive reactance and impedance and RL circuits. Okay, we can have to derive the equation. So this is the derivation. Let us consider RL circuit. So current and resistors, and it is given V is equal to Vm sin omega t. If you write the phase diagram, you can see the phase diagram. Voltage with respect to resistor and with respect to thing which you have to write this diagram. Okay. So coming to here, derive the voltage across the RL circuit. Okay. So this is the derivation. So let us consider RL circuit. V is equal to VR plus VL. So according to this phase diagram, so VR is equal to I into R plus L into di dt. So let us current is equal to I into sin omega. So your voltage here, if you represent current, you can write it this. Then VR is equal to IR. You just substitute the value of I value here, Im sin OR omega theta. So WL, VL you can write it. So L value, I value also substitute here. So if you differentiate, you will get a L is equal to Im into the omega sin theta, so omega cos theta. So you can take out the constant high omega theta 90 plus theta according to this condition. So you will get VL value Im is equal to XL sin omega plus theta. Okay. Next, where XL is equal to omega according to inductive reactance. So substitute in this equation 1, this equation you have to substitute the value of XL value. Once you substitute the XL value, so you will get according to identification sin A sin theta plus B sin of theta plus 90 degrees. So you can write it in this way, and tan theta you can write is B by A. Same the content means same we are using above equation. V is equal to Im is equal to root of r square plus xl square sin omega plus theta. So we can comparing this V is equal to omega sin theta. So you can write it Im is equal to this if you substitute, if you comparing means you have to substitute the equation 1 by, so finally you will get V is equal to IR L square plus XL, so square root of r square plus XL square equation you will get. After that, reactive inductive reactance XL is equal to omega L, L is equal to 2 pi L. So W is equal to omega is equal to 2 pi in a radians, half F will be in frequency. So coming to the impedance according to equation 3. So here equation 3 is there, according to impedance Z is equal to V by I definition. So is equal to root R square plus XL square. So you can substitute XL value according to this. You substitute XL value here, you will get the impedance equation. So if you want to calculate phase angle, so tan theta is equal to XL by R, or XL is equal to omega L by R, substitute value. Finally, you will get a inductive reactance formula, impedance formula, current formula, and power factor formula. Okay, for your easy understanding, how you make like this. Next, explain RL resonance condition and draw a relation phase diagram. Okay. This is resonant circuit diagram. This is the resonant circuit diagram. You can see the circuit diagram. After that circuit diagram, coming to the conditions. These are the conditions for resonant diagram. Okay, features of resonant diagram we are given here. And coming to the phase diagram, this is the phase diagram. You have to write it according to resonance diagram. This is the phase diagram is very important. This phase diagram you have to write it. This phase diagram, and first you have to write the this diagram. And after the phase diagram, write the conditions, whatever conditions is given here, you write the conditions, and current at resonance, this formulas also I have given. This is very simple way. So the phase diagram, how you are going to write, coming to, we'll go down and we'll explain how it will be work. So before, what do you mean RLC resonancy? So it is a circuit occurs inductive reactance become equal to capacitive reactance. According at resonance, the circuit offers minimum impedance and maximum current flow. Coming to the condition in the RL circuit, inductive reactance XL is equal to 2 pi FL we are representing. Next, capacitive reactance XC is equal to 1 by 2 pi FC we are representing. So according to XL is equal to XC, above the definition XL is equal to XC. If you equate it, so you will get a resonance frequency FR is equal to 2 pi. So this you can write this equation, FR is equal to 1 by 2, okay, 1 by 2 pi root of LC. This is the equation, but here we are representing the square root. Okay. Characteristics of resonance. One is an impedance become minimum, circuit current become maximum, power factor become unity, and voltage and current are phase. So if you want to explain phase diagram simple way, you can write these simple words, and the above also I have mentioned. So which is easy, you can explain. Voltage across resistor, we are in a phase with a current. Inductive voltage VL leads to a current is 90 degree. Capacitive voltage VC lag current A by 90 degree. At resonance, VL and VC are equal and opposite, hence they cancel each other. So if the content is useful, please subscribe my channel, share and support. Thank you.